Problem 3 gives us a model, an algebraic model that represents the equation x plus 7 equals 3x plus 3. So we have on this side of the scale we have x and 7 chips, so that's x plus 7, and the scale represents equals, represents the equation. And on the other side of the equal sign, the other side of the scale, we have 3 x's, so 3x plus 3 chips, so 3x plus 3. Okay, we talked in class about a couple different ways to do these. If they give you the answer choices as multiple choice, you could just try each answer choice, substitute in for x until you find the one that works. And I'll show you how to do that when we check our answer. But I'm going to use the picture to solve this one. First thing I'm going to do is take 3 chips off of this side of the scale. So if I do that, I have to take 3 chips off that side of the scale, which is essentially subtracting 3 from both sides of the equation. Because that equals 0. Okay. And then I have x's on both sides of my equation. I only want x's on one side. So I'm going to get rid of 1x there and 1x there, which is like subtracting x from both sides. So I have 4 equals 2x. 2x equals 4. And that's what our model looks like now. 2 cups, 2 x's equals 4 chips. So 1 cup would equal 2 chips, which is the same as dividing both sides by 2. 4 divided by 2 is 2. And on the other side we just have x. 2 over 2 is 1. So x equals 2. Now let's check our answer by plugging that into our original equation. Our original equation was x plus 7 equals 3x plus 3. Everywhere I see x, I'm going to write 2 instead of x. So 2 plus 7 equals 3. This is multiplication. 3 times 2 plus 3. If 2 really is the correct answer, this equation will be true. 2 plus 7 is 9. 3 times 2 is 6 plus 3. And 9 equals 9. Checks out. Good. Problem 4. Similar type of problem. We have a model representing the equation 3x plus 2 equals 11. I'm going to get rid of 2 squares here and 2 squares there. Now I have 3x equals 9. If I divide my x's into 3 groups, I have x in each group. If I divide my squares into 3 equal groups, each group has 3 squares in it, so x equals 3. Using the equation, it would look like this. Subtract 2 from both sides. Plus 2 minus 2 is 0, so I just have 3x here equals 9. Undo multiplication with the inverse operation, which is division. So divide both sides by 3. 3 over 3 is 1, so we just have x on this side equals 9 divided by 3, which is 3. Same answer. So it must be right. But let's plug it in and make sure. 3x plus 2 equals 11. If x really does equal 3, then 3 times 3 plus 2 should equal 11. 3 times 3 is 9. Plus 2 equals 11. Yes, 11 equals 11, yes. Okay. If you check your answer on a problem like this and your equation doesn't work out, where you have something on one side of your equal sign that doesn't equal what's on the other side, that tells you have the wrong answer. That's why we're checking. So if that happens, go back to the start and do it over again. Okay, I'm going to pick up this review with problem 5 on the next video.